Welcome to the talk about resiliency model in the cloud, where we're going to separate myth from fact with respect to how to think about resiliency model in public cloud environment. My name is Pradeep Vincent. I'm a senior vice president in OCI. I've been with OCI pretty much from the beginning for the last 8 years. I joined OCI 8 years back, and I've been involved in many different architectural aspects of OCI throughout in the last 8 years. I'm going to start with a folk tale. This is a folk tale that I heard actually in my school days way back, and it kind of stuck with me for some reason. So the name of the folk tale is called Stone Soup. The story goes like this: a bunch of tired, hungry travelers reach a village with just an empty pot, and they actually go and talk to their villagers and ask them for some food. The villagers do not want to share any food. So the travelers essentially decide to make their own soup, except they actually put a stone inside the soup. The curious villagers ask about, hey, what's going on? How come you're making a soup with stone in it? And the villagers essentially explain that the stone soup is fantastic and they know how to make it. And then they, also claim that, hey, if the villagers are willing to share some ingredients with them, they will also share some of the stone soup with the villagers. So one of the villagers decides to share some garnish to add to the flavor. And one by one, everyone in the village actually provides some form of soup ingredients, including some chicken. That results in awesome stone soup that everyone shares. So, what exactly make the soup taste great? Is it the stone? Is it the other ingredients? That's the crux of the question. The moral of the story, well, obviously there's a moral of the story is that, well, you should be nice to strangers. But the real moral of the story in this talk, in this context, is that fundamentally we have a hard time separating out correlation, causation, and no relationship. When there are multiple events happening, when there are multiple things happening in our life or at work, we sometimes have a hard time separating out what causes what is correlated with what does, has no relationship with each other. That's actually from my perspective, the main moral of the story. With that, let's actually go to the general cloud architecture. So I'm going to start with a very generic, very high-level overview of cloud architecture. And this is not specific to OCI or Oracle Cloud. This is, something that, most of the cloud, big cloud providers pretty much have the same architecture. So we have a notion of regions. A region is a localized geographic area that has, a number of availability domains. Typically, each availability domain is separated by some sufficient amount of distance, usually tens of kilometers, and so that there's isolation from geographic failures, like floods or whatnot. But at the same time, they're not too far apart, so so that it's actually practical to do synchronous replication across them. So it's essentially each availability domain is essentially a one or few data centers that are close to each other, they're tied to each other, and then the availability domain themselves are kind of separated out with some distance across them, and that's the general model that's actually prevalent in the cloud. And the way it's architected, the reason why it's done that way is so that synchronous replication and failovers across availability domains or data centers can actually work. So this is a very typical setup where you have set of resources in each availability domain or data center, if you will, and then there is a failover from and replication across resources in different availability domains, right? And this is very typical. This is not this is not just for Oracle, and I've seen this in other clouds as well. So it's pretty much the same standard. Now, the industry-wide assumption is that the failure isolation via data center isolation in a region provides maximum resiliency. That's the crux of the assumption the industry is making. Now, we actually wanted to take a closer look. Well, to what extent is this real? Is this actually, correlation? Is it causation? We kind of wanted to take a closer look. So we decided to take a look at large-scale outages across hyperscalers. And we wanted to we classified them as, are these related to software or are these related to data center or hardware, right? What we found was that a majority of, the outages are actually caused by software in some fashion or form, right? Now, that essentially leads to a curious next question. Well, so how is the software architecture? If the majority of the outages are actually caused by software, well, then the way software is architected and deployed has to play a key role. So we actually took a close look at how software is architected in the cloud. Now, I'm going to talk about a very generic architecture, and this is not specific to OCI. This is a common pattern or theme that you can find with other cloud providers as well in terms of how the services are architected. So, as an example, let's take object store, right? So we have a front end, which is a regional software, and that's essentially your load balancers or front end web servers and what have you. And then there's a bunch of metadata services or nodes that essentially store metadata about the various objects that you store in object store. And then there's data storage nodes that actually store the data. Imagine you store a bunch of your photographs. Well, the photograph, the actual data is encrypted and actually, sharded or erasure coded and spread across the storage nodes. And the metadata about your photograph is actually stored inside your metadata service. Now, typically, there is a whole bunch of software coupling that happens across the software nodes in different availability domains. As an example, the front end has to failover across data centers so that it actually presents, a singular view to the end customer. More importantly, the metadata services and the storage nodes also need to replicate across each other and failover across each other. Now, one of the important things to note here with this type of software architecture, which is very typical, the software in a region must work together. Why? Because they need to present a single cohesive view to the end customer. As an example, when I store a picture in object store, well, when it's actually erasure coded and actually spread across a bunch of storage nodes, well, the different nodes and different availability domains kind of need to work together to make sure they are stored in a consistent fashion. And then the metadata essentially needs to, be stored in a consistent fashion across availability domains. Sometimes it's like there's some transactional aspect to some of these data writes and data reads, right? So all this essentially means the software across availability domains have a reasonable amount of coupling. As much as we want to separate them out, and as much as we want to make them independent, they actually end up being, somewhat tied together. And we have seen that not just in OCI, but in other cloud providers as well. The challenge with that model and the challenge with that implication is that the software that works together also fail together, right? And when software that's actually deployed at a region level fails, they result in region-wide outages. And that's actually the crux of the challenge. Now, we also took a quick look at, hey, how many of our outages across the industry, if you will, are caused by are actually at regional level or any other level, maybe multi-region, within an AD, things like that. What we found is that majority of large-scale events really impact the region, which essentially goes back to the foundational architectural aspects that the software, even though they're actually separated across or distributed across multiple ADs in a region, they have reasonable amount of tight coupling. They tend to fail together, and as a result, many of the large-scale events happen to be at regional level. So this leads to a fundamental question. Are failures isolated because they are distinct data centers or because of independent software stacks and deployment cadence? That's the fundamental question. Is there a correlation or causation or no relationship between data center isolation and actual failure isolation that we see? And is there correlation, causation, or no relationship between software deployment and software cadence and software architecture on the failure isolation? Does 3 data center region model really provide maximum resiliency? The industry would have you believe that regions with 3 data center results in maximum isolation and resiliency. We challenge that. We fundamentally believe this is a false argument. We believe that in order to obtain maximum resiliency, you need data center isolation, obviously, because that's very important. Data center isolation is quite important because you have many aspects in a data center that fail on its own. You have cooling, you have generators, you have UPS units, you have power itself, as well as other physical geographic aspects. So data center isolation is clearly important. So there is a causation between data center isolation and maximum resiliency. That while that is necessary, is that sufficient? Answer is clear no, as we saw, right? The software architecture within a region always tend to have high coupling, and they have, as a result, they tend to fail together, and as a result, there are more regional outages. Ergo, in order to really obtain maximum resiliency, you also need maximum software deployment isolation, both software and deployment isolation, right? A single region with 3 data centers does not provide both data center isolation and maximum software and deployment isolation. Sure, it actually provides data center isolation. To a large extent, there are some aspects of data center that you actually, it's hard to isolate within a region. As an example, there are some shared, networking components that essentially provide, connectivity across all of them, and they tend to fail together. But ignoring that, to a large extent, data centers tend to be isolated. The cooling is isolated, generators are isolated, and so on and so forth. But on the other hand, software and deployment is a different story. Software, well, as much as we want to try, and we do try, and we, other cloud providers also try to isolate, the software and deployment in each one of the available domains, it's really hard because there is fundamentally tight coupling across them. And that's why we fundamentally believe that multiple regions actually provides the maximum data center isolation along with maximum software and deployment isolation. Cool. So now that we established that, well, let's actually take a look at high availability with low latency. So what am I talking about? High availability with low latency. Well, so what is high availability? High availability generally requires synchronous replication, right? You have, a database nodes, 2 different database nodes. They kind of need to talk to each other and make sure their data transactions are, synchronously replicated. Maybe make sure that caches on both the sites are, in consistent fashion. And this is something that behind the scenes happens in our autonomous database service and excess data service as well. And I'm pretty sure that's true with other cloud providers as well. So fundamentally, high availability requires synchronous replication of some form or the other. Now, if you are to build, a low latency app or service with synchronous replication, you actually need low network latency. Now, let's take a look at network latency. Now, within a data center, compared to across data centers, we actually have orders of magnitude of difference in terms of network latency. Within a data center, we are looking at tens of microseconds of latency. The maximum is like 100 microseconds. Across data centers within a region, well, typically you're looking at like somewhere in the order of 1 millisecond, right? And this has to do with 2 factors. One is the nature of the physical networking architecture itself, where within a data center, there's a lot more. The physical networking architecture within a region or within a data center essentially designed to provide really low latency. On the other hand, the physical network architecture across availability domains or data centers that are far apart fundamentally has to have a different architecture that doesn't allow for extremely low latency. Instead, it has a little bit of higher latency. More importantly, there's also physical distance. When the data centers are apart, there's a physical distance. So, that results in higher network latency as well. So essentially, you're looking at two orders of magnitude difference between network latency that can be achieved within a data center versus across data centers. Now, in OCI, we actually leverage, and I think this is true for some of the other cloud providers as well, we leverage extremely low network latency to build high performance, high availability services. I'm just calling out a few of them. Autonomous database service, block storage service, file storage service, all of them are OCI services. They all leverage the extremely low latency that we have within a data center. What that means is that we essentially, for as an example, for block storage, we essentially have a cluster of nodes that essentially form a volume, their data volume as seen by the customer. And these cluster of nodes, they are in different physical nodes or physical racks, but they are close together and they have very high performance, low latency network across them that essentially allows us to do really fast synchronous replication across them. And that's essentially what allows us to deliver really low latency block storage service. Now, that's awesome. So we can actually build outstanding high availability, high performance services. Then we thought about, well, how do we empower customers to actually build similar services? How do you empower customers to build high availability services or applications with low latency, just as we do internally? That's how we came up with, a notion or new construct called fault domains. A fault domain is really a grouping of hardware and infrastructure that provides anti-affinity and failure isolation within a single data center, right? And if you look at what's inside a fault domain, it really is like, a set of independent servers, independent racks, and they have independent TORs, they have independent, rack PDUs. So there's a bunch of rack level power and data center isolation is provided with fault domains. And in addition to that, some of the aspects of, rack level software is also, independent. So, you essentially have a reasonable amount of, hardware level separation. And you also have a reasonable amount of software level separation, just like as we have with ADs. Now, with the FD model, the resiliency model is actually similar, conceptually speaking, right? So we have multiple FDs, and we have compute resources in each one of them. And they kind of replicate and fail over across each other. And you might notice that this is actually remarkably similar to the AD model, where you have multiple ADs within a region, and we actually replicate and fail over across them. Fault domains, actually, in many ways, similar to availability domains, they actually have some degree of software and deployment isolation, right? Not the perfect software and deployment isolation that regions provide, but still it provides the similar looking, software and deployment isolation that availability domains provide. They also have, rack level hardware isolation, and most importantly, extremely low latency suitable for high performance HA. So fault domains provide all of this, and it actually is a fantastic platform for high availability. And then on top of it, like we just saw, multiple regions provide very strong data center isolation and also maximum software and deployment isolation. Now, if you combine the notion of fault domains with the notion of multiple regions, you actually have the best of breed, which is you have data center isolation, maximum software deployment isolation. And then for high availability, you actually have, fault domains, which provides high availability, not just like, regular high availability, but with really high performance, right? So we fundamentally believe the best way to achieve maximum resiliency in the cloud is to essentially deploy, across 3 fault domains and get the maximum availability with high performance. And in addition to that, use multiple regions to really leverage the maximum software as well as hardware isolation that happens across regions. Keep in mind, when we actually do regions, when we have multiple regions, we actually have it, far enough apart that we actually are there's extremely low probability that even a natural event can actually impact both the regions, right? And with the single region, even with multiple data centers, that's hard to provide. So we fundamentally have a much better opportunity to isolate data centers when we have regions. Now, this is all great, except that, well, how, as a customer, and this is something that customers ask us quite frequently, how do we actually use multiple regions? Isn't it harder to actually use multiple regions? Well, so OCI, we fundamentally architected and launched features to make it easy to leverage multiple regions. As an example, OCI has a bunch of platform level functionality, such as identity and tags and accounts, that essentially are seamlessly replicated across multiple regions. On top of it, a number of OCI services make available a number of critical and key cross-region replication functionality. What that means is that OCI services themselves have built-in replication failover that customers can just use and leverage right off the bat. If that doesn't work, well, obviously you can also, as a customer, you can also build your own cross-region replication and failover for your apps. Well, see, here are some examples of OCI services that actually offer cross-region replication. So we have block storage replication. So we have, and keep in mind, when we actually design all this cross-region replication features, we essentially layered very carefully. And it's because when we do this cross-region functionality, we want to make sure that the cross-region replication mechanism doesn't create strong enough coupling where multiple regions would actually fail. That's actually the crux of it, right? That's the crux of actually providing maximum software and deployment isolation. And we want to preserve that even when we have cross-region replication and functionality on top of OCI. So as an example, block storage replication, if you look at it, there's block storage in every region. They are very independent. They operate independently. They don't necessarily, generally, they don't share metadata or data. And we have a layer on top that actually replicates, storage content from one region to another. The software coupling that comes with it is very much layered so that the core of the block storage from one region to another region is never coupled, right? Similarly, we have autonomous database cross-region replication functionality, which is powered by DataGuard, as well as object store replication. So many of our key OCI services essentially offer built-in, optional cross-region replication functionality that customers can, leverage to build their own cross-region replication. And what we have seen is that mission-critical applications in OCI use similar pattern. We've actually seen them use similar pattern where they actually have, data centers in one region and then data center in a completely different region, and having some form of failover and a replication model across them. As an example, NRI, which actually is a marquee customer of ours, that they essentially have a couple of private regions, also called DRCC, dedicated region and cloud customer. They essentially have two regions in Japan, and each region has 3 fault domains. And using that, they essentially build high availability, low latency, mission critical applications that actually have failover and replication across those 2 regions. Now, one of the key requirements to actually using multiple regions is that the platform actually needs to have a lot of regions, so in order to do the replication. Well, the good thing is that OCI region strategy has fundamentally been centered around that. We have already built out 40 public regions, not to mention the many more that are in the pipeline, and many more that are actually private regions that are actually not included in this 40, and there are a few other Gulf regions and whatnot. So we actually have a lot of regions in the last few years that we have launched so that the customers can actually leverage multiple regions to get the maximum resiliency they need. All right, so to sum it up, takeaways. First takeaway, use data to challenge established norms. This is generally true in life, but it's definitely true in public cloud. Public cloud has been around for a while. It's like 15 years old. Ask for data. If there are established patterns people keep reinforcing, ask for data. Is that actually the right model? Is there something better, right? You might be surprised. Second, we strongly believe maximum resiliency requires multiple regions with multiple very strong data center isolation, along with software isolation and deployment isolation. And then in order to achieve high performance with extremely high performance and high availability, use fault domains. Right. Thank you.